Now we're going to apply our basic set of kinematic equations to a car chase. This is essentially a two-part problem. We have a car traveling at a constant speed of 24 meters per second, and it passes a trooper hidden behind this billboard right here. He's on a motorcycle. 1 second after the speeding car passes the billboard, our trooper on motorcycle sets off in chase with a constant acceleration. How long does it take our trooper on motorcycle to overtake the speeding car? That means essentially to catch up with the speeding car.
We have a car traveling at a constant speed of 24 meters per second, and it passes a trooper, a police on a motorcycle, behind this billboard here. Now, 1 second after our speeding car passes the billboard, our trooper sets off on chase after the car at an acceleration of 3 meters per second squared in order to meet up with or overtake the car. Okay, so our question is, how long does it take our trooper to overtake the speeding car, or how long does it take the trooper to catch up with that speeding car? Now, the key thing is that catch-up time, the time for them will be the time when they both have the same distance away from our billboard right here. So that's the magic thing. We're looking for how long does it take our car to reach a position away from the billboard, which is equal to the same position of the trooper away from the billboard. That's what I'm depicting right here, okay? And so we're going to be looking for how long does it take for this condition to happen, X car equal X trooper. Now, there's a lot of other things we have to do in the meantime in order to get that final answer, okay? So let's go back and look at our diagram here. We have our car. It travels for 1 second at 24 meters per second and before our trooper sets off on its chase. So let's find out, first of all, how long is it taking that car to travel that distance in 1 second? Okay, and so I'm going to call that distance that that car travels in that first 1 second DAB, the distance from point A to point B. So DAB, in order to find that, we're going to look at our equation sheet to find an equation that will help us get that position, that distance that that car travels in time 1 second at constant speed of 24 meters per second. So let's start off with this equation here, that x is equal to 1/2 AT squared plus V naught t plus x naught. Okay, so for this portion of the problem, when I'm looking at things that are happening between point A and point B here, our car is traveling at a constant speed, so it has no acceleration, so that term is 0. We can say that x is equal to 0 right here at the time when the car just passes the billboard, okay, which is the beginning of this segment of our problem. So we could call that 0 meters. So then we'll have that x, we'll call that xab as well. That is going to equal V0t, V naught t. So that's equal to the initial speed of our car, 24 meters per second, times that 1 second that it's traveling, okay, in this segment. And so then that just tells us that our car travels 24 meters in that 1 second. So I've already written that here. The distance the car goes between point A and B is 24 meters. Now, when our car moves that 1 second, it moves 24 meters. At that time, that's where we're going to say that t is equal to 0 for the rest of this problem. I can choose t equals 0 wherever I want and do the problem with respect to that initial point. Okay, so that point in time, t is equal to 0, I'm going to call that time after the car has already traveled 24 meters. I chose that time, t equals 0, after that 1 second because that's the same time when my trooper starts moving as well. Okay, so t is equal to 0 for a trooper when he starts his motion is when I'm going to call t equals 0 here after my car has already traveled 24 meters per second, okay? So now that I already know how far this car traveled has in that first second before I set t equals 0, now I can figure out what's the car's total position or total distance between the billboard and this place right here, point C, where the car and the trooper reach the same distance away from the billboard. Okay, so we're going to find that equation, which I'm going to call the equation for X car, the position of the car at point C. Okay. So I'm going to reuse this same equation that I wrote here. I'm just going to use different quantities. So we've got our final X position, which will be what I'm calling X car. The total distance between the billboard and where that car ends at point C equals 1/2 AT squared plus V0t plus X0. Okay, so for this segment of our problem, this is going to be with respect to, remember I was talking about how we're going to set t equals 0 at when the car reaches point B here. So this equation is going to be with respect to our point t equals 0. Now, again, the car has a constant acceleration, or sorry, constant speed, so our acceleration is going to be 0. The car always has a speed of 24 meters per second. This t is unknown. That's the unknown we're trying to solve for right here, okay? And then this x0, that's the time that that's the position that our car already is at t equals 0. And so the car we already calculated is going to be at 24 meters away from the billboard when we set t equals 0. So that's going to be 24 meters. So then I have an equation for the position of our car here at point C, and that is going to be V0t plus X0. So that's going to be 24 meters per second times time plus 24 meters. Okay. So I'm going to put a box around that because we're going to use that equation here again in a minute. Now we need to do the same equation for the trooper. We need to get an equation for the trooper at point C with respect to time t is equal to 0. So we'll call that x trooper at point C with respect to t equals 0 second. So I'm going to call it x sub t for x trooper equals 1/2 AT squared plus V0t plus X0. Now for our trooper, he has a speed, or it could be a she, not speed, an initial or a constant acceleration of 3 meters per second squared. 3 meters per second squared, okay? Starting from rest, so our initial speed for our trooper is going to be 0 meters per second, so that term is 0. And we can say that the initial position here for our trooper, we can also set that to be x equals 0 meters. The same thing that we did for the car. At this point here, right at the billboard, the car had a position of 0 meters as well. Okay, so that's 0. So the position for our trooper is going to be 1/2 times his acceleration, 3 meters per second squared, times t squared. Okay, so we need to set these two equations equal to each other. Okay, as the time it takes for the position of those two to match is what we're solving for in this problem. So we've got both of these equations, we set them equal to each other. The only thing we don't know here is t, and so we'll be able to solve this equation for t. So if I set both of those to each other, we've got 24 meters per second times time plus 24 meters is equal to 1/2 times 3, that's 1.5. So that's equal to 1.5 meters per second squared t squared. Okay. Now I'm going to rearrange this equation and move all these terms on this side over to the other side of the equal sign. Okay, so then that becomes 1.5 meters per second squared t squared minus 24 meters per second times t minus 24 meters. That all equals 0. Okay. Now, if you remember, maybe from algebra, that this is a quadratic equation. We've got a quantity here, which I'm going to call a, times t squared. And then we have a quantity, which I'll call b, times t. And then we have this final quantity here, which I'm going to call c. Okay, and it's not being multiplied by our variable t. Okay, so this is a quadratic formula. And if you remember quadratic formulas, how do we solve for them? So this is the form of ax squared plus bx plus c. That all equals 0. So we've got a x squared plus bx plus c, that all equals 0. Okay, so the x, that's our unknown, that's our variable that we're trying to solve for. To solve for a quadratic, you use the quadratic formula. And so the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's our quadratic formula. So we're going to apply this to our equation up here that we got in order to solve for our unknown t. Okay, so if we do that, then we'll have that t is equal to negative b. So for us, that would be negative the term negative 24. So minus 1 times minus 24. So that becomes positive 24. So the minus b term here for us would be 24. I'm going to drop the units for now. Plus or minus, we've got the square root of b squared. So that would be minus 24 squared. And then minus 4a is 1.5. C is minus 24. And then we divide that all by 2 times a, which was 1.5. This becomes 24 plus or minus the square root of. The stuff underneath this square root sign here is equal to 720. And then that's all over 2 times 1.5 is 3. So t can be 24 plus the square root of 720 over 3, or t could be 24 minus the square root of 720 over 3. Now, we're not going to be looking for a negative value for t, so we're going to want to choose the value here that will use our positive from the plus or minus on this part right here. So the quantity that we're going to get for t is going to be t is equal to 24 plus our square root of 720 divided by 3. So we want to take the positive quantity of this expression here. And when we do that, we find that t is equal to 16.9 seconds. So it takes 16.9 seconds for our trooper to catch up with the car. All of that work in order to get us this number right here.